Hi everyone, Kanwar Singh, CEO of Skyline Nav AI. We've had a long-standing partnership with MIT. My co-founder went to MIT and got his PhD from there. So at a high level, our background expertise is in computer vision, manufacturing, patents, hardware development, and scaling. And we have been working primarily with clients in the United States and Europe. Last week, I was actually in Taiwan. That was one of our first trips in Asia. And we're looking for folks who are looking for GPS independent navigation for cars, trucks, drones, aircraft. That's what our subject matter expertise is. And then you might ask, well, why do you need a GPS independent solution? Well, there's many reasons why. First off, if any one of you have lived in complex terrains, think of urban areas, mountainous regions, you're driving through tunnels, highways, multi-level highways, you may have struggled with localization. And so challenge is you're connecting to the satellite to get your location back, and it's not very efficient. So that's one of the reasons you want to think about not just GPS, but fusing GPS with other modalities such as the camera. You also have these situations where GPS could be denied. That's happening right now in Eastern Ukraine and in Middle East. It's being denied, spoofed, and so it's very challenging for folks on the ground when they're doing regular things like getting from point A to point B or opening up their cell phones and not being able to get the rides that they need on apps like Uber, Lyft, etc. So that's where we come in. We have solved the issue of GPS denial and a GPS independent navigation system that can work on ground and also in the air. And we estimate that if a technology like ours was deployed at scale, it can help save people billions of dollars a year in fewer time that is saved, but also fuel costs that people end up spending a lot of time on because they don't have good localization. So how does our solution work? Well, at a high level, we use the camera and we also use the storage and compute on board a car or a drone or an aircraft. And then that imagery is coming in as you're moving from point A to point B. We have computer vision models that I'll talk about in a second that are able to pick up on different features around you. Think of buildings, think of mountains, think of trees, think of land, ocean, you name it. Just like you and I as human beings, we can figure out where we are by looking what's around us and comparing that with a map. We do the same using pre-computed, pre-processed, two-dimensional and three-dimensional satellite data sets. So you download our capability, and it is designed to run on the edge. So there is no connectivity required after you have the satellite data sets and you have our algorithms downloaded, which we recommend doing it at least once a year because things around you don't change very often. Now, if there's been natural disasters, think of earthquake, hurricanes, etc., things will change. And that's where you want to bring in the latest data set around you. And so once you have it and we've pre-computed, pre-processed everything, takes a few minutes, now you're good to go. So as you're driving or flying, the camera is taking in visual information, comparing that with the pre-downloaded satellite datasets, and our algorithms are able to give you a location back, and you can now navigate with or without GPS. So here's our secret sauce. We have different types of computer vision models in the air and on the ground that are able to deliver on these various capabilities. In fact, you go to skylinenav.com today and you can explore the city of Chicago with no GPS. We've also just last night published our first set of results where we actually flew a drone in different parts of the US, and we are able to geolocate simply by using the camera on the drone. This is two-dimensional, what you're seeing on the left. And then the city of Chicago is using a Skyline train-based approach, and you'll experience 95% of the time we can get you 5 meters or under on air or on ground. Something we have also recently launched is a semantic-based approach where we're able to pick up on different restaurants and intersections and fuse that to give you more accurate positioning. So in this picture, this actually is not at MIT, but at a competing school, Harvard. And we are able to pick up on different intersections and restaurants and businesses in that vicinity to tell you, hey, this is where you are. Now, imagine the possibilities of having more accurate positioning and navigation. So on the left, you're seeing the current day experience of urban canyons. And we have published a bunch of case studies on our website. San Francisco, Atlanta. I experienced this in Taiwan last week. I've experienced this so many times in Boston. It's unbelievable, right? So the big blue circle, I call it that big blue circle of death because you're like, where am I and how do I get to my location? And on the right, our technology kicks in, and simply using camera, we can get you 5 meters or under 95% of the time. And you fuse our capability with inertial sensors, and or LiDAR, and then centimeter level accuracy is also possible. So you can see on the left the land-based results and how we're able to pick up on that. And on the right, you have air-based results. Again, go to the website. You can play with our API. You can play and see with the demo video we've posted recently of the drone footage. And our capability, the beauty of it is we've already trained the models and it's ready to go worldwide. We've already proven it out in 40 regions around the world. And if there's a region of interest that you have, please reach out and I'd love to work with you. You can bring your own imagery or we can fly out to you and we can prove out the capability works with you in action. So how are customers using our capability today? So we are working with large companies like BAE Systems and Carefort. So BAE Systems has its own camera system, and our capability is running on top of that camera system to do GPS independence, to do object recognition and autonomy. With Carefort, they're one of the premier inertial system companies, and our capability is being fused with their inertial sensing capabilities. We have published the demo of our BAE Systems collaboration, so you can go to our website and check it out. I'm also very excited to announce that we have an in-house design of a ground robot and a drone, which we're actually manufacturing right here in the United States. We just launched this. You're actually one of the first group of people to learn about it. So it's called Blade Next, and these are tactical robots and drones, low cost, affordable. The ground product is $5,000 or under, depending on the configuration. And we're offering the drone at $2,000 or under, depending on different configuration and the model type. And it's running our software. And we've also added new features for object recognition and also for autonomous operation from point A to point B. And most importantly, these products can navigate in a GPS-denied environment, and they're secure and encrypted, mission ready. And so what we are here for is we are seeking customers who have case studies and areas where you're struggling with localization. And these are all the different sectors, but there could be others as well that you're interested in, and we can help you solve that by using the camera. We just need three things: camera, storage, and compute. And we can make our software work through the API and the SDK. The API does require cloud connectivity, but the SDK, which is our software, is designed to run on the edge with no connectivity requirement. No Wi-Fi, no cellular, no GPS. I'm happy to answer any questions you have. Thank you.
Thank you, Kanwar, very much. So what about fog and other elements that could complicate things a little bit?
Excellent question, Ariana. So with fog, there's certainly special cameras that are able to clear up the fog or even in snow or windy conditions, right? So we are relying on the camera that you have installed on the edge. And the same thing applies even at nighttime. So, if you have EOIR cameras, then certainly we can pick up on that. That's actually been our collaboration with BAE System, where our software is running on top of an EOIR camera and can look through at night. So if you're using an iPhone camera, so we have an iPhone app as well to demonstrate our capability, well, these things won't work very well in fog and also at nighttime unless you have good lighting condition. And so that's the dependency we have on the camera system. That's why we tell clients, fuse our capability with IMUs and LiDAR if you have available, because then you have an end-to-end solution that would work in any type of environment.
Okay, and tell us a little more about the business model. How are you working with a corporate, for example?
Yeah, absolutely. So typically clients would come in and they would purchase our API and SDK, and we charge an annual fee for that. And we don't actually make money off of the API SDK. It covers our engineering costs, so we can ensure that our product is working with your hardware configuration. So if you have specific camera types, well, it's probably going to require some calibration on our side to make it work. And so that's all covered in the API and the SDK. And for every car, truck, drone, aircraft that you install our capability on, we charge you a small license fee. And it can be negotiable. So for example, we're talking to a company right now that wants to put our stuff on 10,000 drones next year, right? So they're not paying the full retail price, and we're negotiating, and we have come to a conclusion on what that's going to look like. So that's what we're interested in. Automobile manufacturers, drone manufacturers, if you're interested in incorporating, we'll work with you, and would love to have our technology integrated.
Thank you very much.
Of course, my pleasure.
Okay.
Thank you.